In this lesson, we will consider searching for the building units in intermetallic compounds. First, I have to calculate the adjacency matrix. So I run AutoCN, Options, Matrix tab. I remind you that you should use the solid angle method to calculate the adjacency matrix for the intermetallic compounds. Now I have calculated the adjacency matrix, thus I can use the nanoclustering procedure for searching for the building units. The tiles or nanoclusters can be taken as building units. I use compound, auto-determine, nanoclustering to open the nanoclustering window. Let's consider all options in it. The maximum number of clusters is the maximum number of nanoclusters in the representation. The number is unlimited if this value is equal to 0. The maximum number of shells restricts the maximum number of shells in each nanocluster. If this parameter is 0, the number is unlimited. The one-atom cluster option permits existence of one-atom nanoclusters. This option is required for the structures where some equivalent atoms are interconnected. The enumerate layers option considers all possible sizes for multi-shell nanoclusters. Otherwise, maximal possible size will be assumed for each nanocluster. The Save All Nets option automatically saves underlying nets in a new database with the C suffix when computing several structures. The Search by Cations options allow choosing the centers of nanoclusters only among cations, or cations will necessarily be taken as centers of nanoclusters, and some other nanoclusters will be searched among other atoms. In this case, Topos Pro ignores the symmetry of cation positions, so you may enforce Topos Pro to consider some special sets of nanoclusters that do not fit the principles of the nanocluster method. The Consider Empty Clusters options allow considering voids as centers of nanoclusters. Topos Pro treats all unoccupied Wyckoff's positions without variable parameters as possible centers of nanoclusters. In the output data, they are designated as ZA with Wyckoff position in parentheses. You may consider only representations containing such empty nanoclusters, or all representations both with and without empty nanoclusters. To find the composition of empty nanoclusters, Topos Pro considers all contacts between ZA and the atoms that have solid angle of the corresponding face of the Voronoi-Dirichlet polyhedron of ZA no less than minimum omega value. The Porous Structures options allow searching for representation of a porous structure, like zeolite, as a set of tiles or rings. The structure should be represented together with its dual net. In this mode, the Porous Structures units options are valid. That allows considering as nanoclusters only tiles, only rings, or both tiles and rings. You can find more information about tiles and dual nets in our lesson Computing and Analysis of Natural Tilings. The Consider Solutions options allow outputting all solutions, or only those where every nanocluster has at least one atom in the outer shell belonging to this nanocluster only, or only those where nanoclusters have no common atoms. The largest number of representations is given by checking one atom cluster and with all clusters options. Other options should be set by default. Anyway, the one atom cluster option should be checked only if no representations were found with this option unchecked, because in general nanoclusters should be multi-atomic. So it is better to try initially with all clusters and other options being default. If the computation is too long, you can change options. If you want to check some non-standard set of nanoclusters, you may specify positive oxidation degrees for their centers and use search by cations options. So I use set by default options and the option with all cluster. There are 41 representations. They are ordered by the number of clusters. These representations contain empty clusters with ZA centers. These are Wyckoff positions of the ZA. I select the first representation and click the option Generate Nets, which will generate the underlying nets for this representation. Topaz Pro offers me to create a new database with the C suffix containing the underlying net. I open the txt file, which contains the output of the nanoclustering procedure. These are the 41 representations. The detailed information of the chosen representation shows that it consists of 2 nanoclusters. First nanocluster has the magnesium-9 atom in the center. In the first shell, nanocluster has 16 atoms, in the second, 44. This is the coordination number of the atom. This shows a number of such atoms. The line summarizes the information about the first shell of the primary nanocluster. It means that shell has 16 vertices, 42 edges, and 28 faces, and that the 12 vertices are 5 coordinated and 4 vertices are 6 coordinated. There are 44, 5, and 6 coordinated atoms in the second shell. To define the general type of the shells of nanoclusters, we use the signature VEF, where V, E, and F atoms are projected to vertices, edges, or faces of the previous shell or the inner core. For example, the magnesium-8 6 coordinated atoms are of the type V. Magnesium-2 6 coordinated atoms are of the type F, and aluminium-2 6 coordinated atoms are of the type E. The number of atoms corresponds to the initial magnesium 37.34 aluminium 61 structure and allows you to easily construct the nanoclusters with isocrest. Ergo, I am running isocrest, drawing the picture and selecting all magnesium-9 atoms. Then I draw the first and the second shell of the cluster using the button Grow. In the same way, I can draw the nanocluster with aluminium-14 center. I can change the color of the atoms by magic wand button. For example, I have colored all atoms of type V in red and atoms of type F in blue. Now let's look at the database with the C suffix. I open the Crystal Data window. In the Command tab, you can see the composition of the clusters. This record means that atoms aluminium and magnesium in the underlying nets correspond to 63 atoms and 61 atoms cluster respectively. You can see that the cluster centered by aluminium-1 in the Adjacency Metrics tab is in contact with 12 other clusters, 6 aluminium plus 6 magnesium. The cluster centered by magnesium-1 has 12 valence and 4 hydrogen bonds. Pay attention that in the underlying net, each valence contact corresponds to a pair of joined clusters having at least one common atom, while hydrogen bond contact designates bonded clusters that are connected by bonds between their surface atoms. We can classify the topology of the underlying nets in two ways: ignoring or not ignoring links between the bounded clusters. For this purpose, you can set the bond type option for hydrogen bonds to none or to atom respectively. If we ignore bounded clusters, we will have 12-12T2 topology. If not, MGCX. You can calculate coordination sequences for the intermetallic compounds and search for the compounds with a given sequence in any database. Let's see how to do it. I'm selecting all compounds and running the isotest program, which allows you to calculate and save the coordination sequences. In the Command tab, you should check the options Continuous Calculation and Save Topology. In the Topology tab, you should check the option Full Representation Only. Now I right-click in the database window and specify the Show IDS option to show information about coordination sequences in the crystal data window. Now we can see the coordination sequences for all compounds in the crystal data window. I also can construct the distribution of the coordination sequences. I apply a database distribution. Then I open the Sublattice tab, choose the Sublattice topology as distribution type, and create the List by Create Distribution button. The list allows you to find the structures with the given coordination sequences. For example, I have found all structures having 12 atoms in the first and 50 atoms in the second coordination sphere. The structures can contain the same nanoclusters as considered in our lesson. So in this lesson, we have considered all options of the nanoclustering procedure, which are used for the searching the building units. For more information about the possibilities of the program package Topos Pro, you may address to our lessons and webinars on our website scdms.ru.